Okay, so far we've looked at settings that involved a single random variable, but many times in statistics they require us to combine two or more random variables. So earlier, we've been examining this Pete's Jeep tours, right? So we understand that we used X as a random variable to represent the number of passengers on a randomly selected half-day trip for Pete's Jeep tours. Okay. At the top of this is the chart that this is kind of like where we belong, where we began, right? So X is representing the number of passengers for his tours. They needed two to begin, to even have the tours start, and the Jeeps fit no more than 6 people. Okay, so let's say now Pete's sister Erin, who lives in a nearby tourist area in another part of the country, is impressed by the success of Pete's business. So she's going to decide now to join the business, running tours on the same days as Pete in her slightly smaller vehicle under the name Erin's Adventures. After a year of steady bookings, Erin discovers that the number of passengers Y on her half-day tours has the following probability distributions. Where are we? Okay, so here is the probability distribution for Erin. Okay, so Y is representing her number of passengers. Okay. Okay. So now let's say I want to start to talk about both of these random variables. So combining these random variables. Okay. So now I want to talk about something more like how many passengers T will Pete and Erin have on their tours on a randomly selected day. So combining that, right? So now it would look something like T, which is both of theirs, would be his passengers plus her passengers. Okay, so let's see kind of what finding the means and the standard deviations, what happens there when we have when we're combining. Okay, so when we combine the means of two random variables, all we have to do is add them. Okay, so for, I'm just going to do it under here. Okay, so for their combined passengers would be the mean of X, or the expected value of his passengers, plus the expected values of her passengers. So on the previous page, that was 3.75 plus 3.10. So the expected value of both of their combined passengers would be 6.85. So they will have an average total of 6.85 passengers per day combined between their two, tour businesses. Okay, so now let's start to talk about how much variability there is in the total number of passengers who go on Pete and Erin's tours. So, in other words, now we're going to start to look for standard deviation. Okay, so let's think about the possible values of let's think about the possible values of T equals X plus Y, right? So the number of passengers of X on Pete's tours is between 2 and 6, and the number of passengers on Erin's tours is between 2 and 5. She had that smaller vehicle. So the total number of passengers T can be anywhere between 4 and 11, okay? I'm assuming she's not going to run tours either if she has less than 2. So they'll have minimum 4, but no more than 11 if they both max out their passengers. So the range of T then would be 7, right? So if X has to be anywhere between 2 and 6, and Y anywhere between 2 and 5, that means that the range for T would be anywhere between 4 and 11. Okay. So there's more variability, obviously, then in the values of T than there are in the single values of X or Y alone. So this makes sense, obviously, because the variation in X and variation in Y both contribute to the variation in T. So let's start talking now about standard deviation, because we know we don't typically use the range anymore anyways, or it's just not as descriptive, or it doesn't mean as much as we know the standard deviation does. So if we had the probability distribution of the random variable T, then we could calculate our standard deviation of T. So let's try to construct this probability distribution starting with the smallest possible value. So T would then equal 4. Okay. Okay, here we go. So the only way to get a total of 4.
Kathy Campbell, if you're in the building, can you please call the front office? Kathy Campbell, if you're in the building, call the front office.
So the only way to get a total of 4 passengers is if Pete has 2 passengers and Aaron has 2 passengers, right? So if I want T to equal 4, that means X equals 2 and Y equals 2. Okay. So we know that the probability that X is equal to 2 is 0.15, and the probability that Y is equal to 2 is 0.3. Okay? So if the events X equals 2 and Y equal 2 are independent, then we can multiply these two probabilities. Otherwise, we're stuck. In fact, we can't calculate the probability for any value of T unless X and Y are going to be independent, okay? So if knowing whether any event involving X alone has occurred tells us nothing about the occurrence of any event involving Y alone, and vice versa, then X and Y are independent random variables. So probability models often assume independence when the random variables describe outcomes that appear unrelated to each other. So you should always ask whether the assumption of independence seems reasonable. So, for example, it's reasonable to treat the random variables X and Y separately, right? Because the siblings operate their trips in different parts of the country. All right. So, in other words, you can't have a passenger on his Jeep Tours and her Jeep Tours at the same time. So they're independent of each other. Okay. So now that we know that, we can calculate the probability distribution of the total number of passengers for that day. Okay. So our new chart then would look like this. So now we have T, our values of our passengers. So we talked about now this, that it's anywhere from 4 to 11. So So the probability then is going to be found now that we know that they are independent. We now know that we can multiply them to find the probabilities of both of them, right? So that was the point, I forget what it was, right? So 0.15 for his 2 passengers times 0.3 for her 2 passengers. So 4 passengers would be 0.45. So again, his passengers were 2. That was 0.15. Okay, and she was 2 passengers. That was 0.3. Multiplying them, that's where the probability of 4 passengers were. Right. So 5 passengers would then be 1/3. 0.135, 6 passengers, 0.235, 7. Again, all I'm doing is for 8 passengers, taking their two probabilities and multiplying them together. And then you have several different options, right, for 7. So then you'd have to add them. So I'm just going to complete the rest of them, because ultimately we're not going to be doing this in the long run, just kind of showing you where this is coming from. Okay. So now I have a probability distribution that's the combination of x and y for each possible value of t, okay? So now that I have this, I could go ahead and find my mean and my standard deviation, but I kind of already went with the mean, right? So the mean, we knew that I could just add the two means together, okay? So the mean of t is just going to be the mean of x plus the mean of y, so it was the 3.75 for him plus her 3.1 expected value, give us a mean of 6.85. Now that I have this, I can actually calculate it too, right? So I could do 4 times the probability plus 5 times the probability plus 6 times the probability and do the whole thing, okay? But it's not necessary. It's just going to come out that you can just combine the two means separately, okay? That doesn't work for the variances though, okay? So when we take the variances, what we're going to do is the value minus your expected value. We're going to square that and multiply it by each probability and add it to each one of your values, right? So then 5 minus 6.85 squared times 0.135 plus, and the last one, 11 minus 6.85 squared times 0.005, okay? And you're going to end up with 2.0775, okay, which is not the standard deviation. So the standard deviation I'm going to find by taking the square root of 2.0775, which is about 1.441. Okay. So this obviously is very different than if we were to add them together. Okay, so if you don't remember it or have it written down, the standard deviation for x on two slides ago was 1.0897. The standard deviation of y was 0.943. Okay, if I was to add these two together, I would end up with 2.0327, which we now know is not the answer. Our answer is 1.441. Okay, so let's understand where this comes from. So in order for you to be able to find your combination of your two random variables, their standard deviation, you have to add the variances. You can never add the standard deviations, okay? So this is very much the same as what we have done in the past. This is no different than what we did when we actually did the linear transformations, okay? We did the same thing. So the variance for x, which you could find by just squaring the standard deviation that I had on the last slide, okay? Or you could go back to the past video
which you're not going to do, but you could find where we had calculated it. So the variance for y and x are right here, okay? So now to find the standard deviation, we'd have to add together my two variances. That's going to give us that 2.775 that we saw when I did it in longhand. Now to find the standard deviation, I'm just going to take that and square root it. Okay, so again, this is very similar to what we have done in the past. All we have to make sure we do is to never ever add the two standard deviations. You always add the variances and then square root the variances. And again, they do have to be independent. Okay, so let's take a look at this quick question and be done with this video. Okay, so a college uses SAT scores as one criterion for admission. Experience has shown that the distribution of SAT scores among its entire population of applicants is such that a math score has the following mean and standard deviation, and here is the standard deviation and mean for your critical reading. Okay, so what are the mean and standard deviation? Okay, so of the total score. So you're looking for the total score, which would be x plus y. So a new random variable being the total score for a randomly selected applicant is going to be their combined random score, math score, and reading score. Okay. So to find the mean of t, I'm just going to take the mean of x plus the mean of y. That's easy enough. 519 plus the 507 means I have a mean or expected value of 1026. Okay. Now remember that in order to figure out the variance and standard deviation, we do need to have independent random variables. Okay. The variance and standard deviation of the total cannot be computed in this problem. SAT math and critical reading scores are definitely not independent of each other because students who score high on one exam tend to score higher on the other. And so we're not going to be finding the standard deviation or variance and then standard deviation of these problems or of this problem. So again, in order to do that, you'd need them to be independent of each other. Otherwise, you cannot put them together. You can't combine them unless they're independent. Okay, that's it for this one.